Hello, I'm Urian Miller, and this is my package alignment project that uses QR codes. Here, I have a QR code that represents a package. It is attached to a servo. The servo will rotate so that the package is always properly aligned. First, I will talk about QR code detection. I'm detecting QR codes using the OpenCV Python package. When a QR code is detected, my code does several things. First, it will try and decipher what the heck the QR code means. Shown in the bottom left here is what it's detecting, and that will be decoded into some information. In the console below here, and at the top of this frame, you can see what it is decoded into. This one says, handle with care. That's the information encoded in this QR code. In addition to getting the information out of the QR code, my code also looks at where it is in the frame and at what angle of rotation it's at. This information is displayed in the frame by drawing the box around it so you can see the orientation of it. Next, I'll talk about the control system that corrects the angle of these QR codes. My laptop is taking frames with its webcam, which you're seeing me with now. That webcam is looking for QR codes, and if one is found, it will try and find the priority QR code. This is the rightmost QR code. So if two QR codes are detected, one is picked as the priority. It's always going to be the rightmost QR code. Even if they're switched, it's still the rightmost QR code. For the priority QR code, it's annotated in green. Next, I want to find what's the difference between how this QR code is currently oriented and where it should be oriented. To calculate the current angle, I look at the angle between these 2 points. That gives me an angle of orientation, and I compare it with what I think it should be oriented. In this case, I read the data to find where it should be oriented. This one says handle with care, which means it should just be oriented horizontal. This QR code says this side up, which implies that its top should be here, and I can get the desired angle out of that. The angle difference between how the QR code should be oriented and how it is oriented is sent over USB to the Arduino. The Arduino is always listening for these angle differences, and when it's told that there's some angle difference, it will rotate the servo to correct for that difference. In total, showing it again, when a QR code is mounted on the servo, it will be rotated to always be in the correct position. My system has a physical limitation due to the servo. It can only rotate 0 to 180 degrees. So I can put this in a position where the servo is not able to rotate and correct the angle. You can see in the console that it prints that the angle limit is reached. But if I bring it back into its working range, it's able to correct the QR codes. The application of this is picking up a package in the correct orientation. Here, this package should be horizontal, but different packages may have different orientations. This package says this side up, and the servo will always put that side up. In this case, the servo is connected to the QR code directly, but the actuator could be something as a robotic arm that picks up the package. In addition, these packages could be moving on a conveyor belt, and the closest package could be chosen. So here there's 2 QR codes, and it will always pick one like closer on the conveyor belt as it comes toward it. It still detects all the other QR codes in the frame, and they could be used to plan ahead for the robotic arm. In addition, these QR codes could contain a lot more information than just their angle. They could contain information for where a robotic arm should put it next, after it picks it up. As a takeaway, I learned a lot about how QR codes worked, and I had fun implementing a closed-loop control system using QR codes and serial communication. Thank you.